All right, good morning everybody and welcome to our ending lesson in Unit 4. We have Unit 4, Lesson 2. This is called Number of Solutions to Linear Equations. So far we've only looked at when there is one solution. So we get one solution when we have the two linear equations or two linear equations. And if they have a different slope, like this line here, let's look at the slope of this line. It rises 1, runs 1, rises 1, runs 1, starts at 0, 0. So this is the line y equals 1x, because it rises 1 and runs 1, plus 0, or y equals x. This is the y equals x line. We'll call it line 1. And then we have this second line here. Remember the equation in slope-intercept form for an equation is y equals mx plus b. So here we have a situation. Let's find a little point where the line crosses, like here. The next point where it crosses perfectly is it goes down 1 and right 3. So we have y equals down 1, right 3, negative 1 over 3 for the slope. And then we put in x. And then the starting point, well, this is a really difficult starting point, 0, 1, 2. I'm going to just guesstimate it as 2.7. There's a fancier way to find that exact point, but I think that's pretty close. We'll just call that line 2. And that would be one solution. This point in space meets, and it looks like it's about, I'd guess, 2.3. This point of location, possibly 2.3, comma, 2.2. And we could find that graphically. Let's find the precise location if we use substitution, y equals x. Okay, well, if y equals x in equation 1, I can go to equation 2 under substitution and replace this y with x. We'll find the precise location here. Let's say we have x equals negative 1/3 x plus 2.7. I'll add 1/3 x to both sides. That cancels, ran out of space. 1x plus 1/3 x is 4/3 x equals 2.7. Now I need to multiply by 3 over 4. And I get my answer. Let's see. 1x equals 2.7 times 3 equals 8.1 divided by 4, so I was a little bit off. 2.025. X equals 2.025. 2.025. It doesn't matter too much for this lesson, but we know that two linear equations cross and they have one solution. Now, you might get something that has what we call no solution. Now, that situation is when if they have exactly the same slope. Both equations have the same slope. And if we look at this example pulled from the article in Khan Academy, we see that we just talked about one solution. We'll keep that in yellow. A system of linear equations has one solution when the graphs intersect at a point. Now, look at this situation. Here's a situation where, if we look at this, find this lattice point here. Looks like we have the same thing here. It's the same line as this one up here. This was y equals negative 1/3 because it goes down 1, right 3, x plus 2.7. And then we look at this line down here. Well, it has a similar thing going on also. If I look at that point and that point, it's also going down in right 3. So this line is y equals negative 1/3 x, but it's at 1.7. What do we notice about line 1 and line 2 in this situation? What is the same inside of these two equations? What is the same? What is identical. And we look at it, we say, oh, well, if I look at y equals mx plus b, both equations have slope -1/3. They're both exactly the same. Since both lines move identically, forever, they never cross. They will never cross. And therefore, if they're never going to cross, they're never going to have a solution. So we say that they have no solution, okay, when the graphs are parallel. And when are the graphs parallel? Well, the only time that they're parallel is they're parallel when, circle that in your notes, they're parallel when the slopes are identical. That means they rise and run the same. They rise over run the same. And that would be our situation with no solution. No solution. There is a third option that rarely comes up, and that's called infinite solutions. And that's hard to see on a graph, but infinite solutions means that they're the same line. That means they have the same slope and the same y-intercept. So if that's the situation, it's really hard to see it on a graph. Here it says the infinite solutions are the exact same line. Okay, well, let's imagine that this line is crossing right here, and then it next crosses over here. So it rises 1 and runs, well, it rises 1/2 and runs 3.5. That's a tough one to do. So this y equals, rises 1/2, 0.5, and it runs 3.5. X, we'll say it's about 1.6 plus 1.6. So here's one line here. We can change this to, if we double both these numbers, we could say that this is y equals 1/7x plus 1.6. So this is actually exactly the same. Now let's say I made everything, I multiply everything times 7. So this line could also be 7y equals x plus, and I need to multiply 1.6 times 7, 11.2. These are all the same line. All the same line. The only difference between this line and this line is both sides here are 7 times larger. But that keeps it balanced, because if I multiplied the left side by 7 and the right side by 7, yes, they look different, but they're exactly the same. So you have to, typically for no solution, you have to look algebraically, and we'll see what that algebraically. Let's take a look at what that looks like. We'll go relatively quickly. These are all in Khan Academy. These examples are from Khan Academy, not from your book. And this article was assigned to you. So we are asked to find the number of solutions to this system of equations. Just by looking at the graphs, you can tell that if I continue this graph here just a little ways longer, eventually they're going to cross at some point. So I'm going to get a solution graphically. If I was to continue this, it's going to hit somewhere over here. This would be your solution. And the location of that solution is kind of hard to find because our graphs didn't go far enough. So maybe we need to solve it algebraically. So we have this line's in slope-intercept form, y equals mx plus b, but this one's not. Well, I know you can graph them by taking this equation and subtracting 3x, so it would become minus 3x on the right. Or you could use substitution. Let's try substitution to find our answer. We could take this negative 6x plus 8 in equation 1 and substitute it into equation number 2. So I'm just going to put it right there for y, because it says y equals this, so I can replace that. So I get 3x plus, now use a parentheses, negative 6x plus 8, then the equal sign, then negative 4. All right, the positive distributing is not going to change this problem at all, so let's take a look what it looks like. 3x minus 6x plus 8 equals negative 4. I distributed, now I combine like terms, negative 3x. These two guys combine to make negative 3x. 3 minus 6, negative 3. Plus 8 equals negative 4. Subtract 8. And we have negative 3x equals negative 12. So I divide by negative 3. And I get x equals positive 4. Cool. All right, well, I have both these equations have been solved for x already, so I'll just pick one. Y equals negative 3 times positive 4 minus 4. Y equals negative 12 minus 4. Y equals negative 16. All right, so I have my x and y. So I always give my solution as the location x, comma, y. So find your x, put it in there. Find your y, negative 16. And then you have your answer. How many? Find the number of solutions. This is one solution. Oh, solution. Sorry about that. One solution. Here's an example with no solution. We're asked to graph this one. They're both in slope-intercept form. You can see y equals mx plus b, where we typically circle that and put a square around this. So when I square this, I see that that's negative 3 and negative 3. The slopes are the same. Then I have to ask myself, if it's no solution, then the y-intercepts, this one goes through 0, 9. And this one goes through 0, negative 7. So they have different y-intercepts. And if we look at it graphically, go up to 9, and the slope is negative 3 over 1. So I just count 1, 2, 3, write 1, 1, 2, 3, do it a couple times. Use something straight to draw. It's not the perfect drawing, but it's pretty close. This one also is negative 3 over 1, so I just have to go down to 0, negative 7, and then I'm going down 3, right 1. Uh-oh, ran out of space. I can also go the other way, up 3 and left 1. Anyway, I'm going to draw these two lines. And now that I'm done drawing them, I can see that they'll never cross. Same slope, different y-intercepts. They never cross, so therefore it's no solution. And then our last one would be an example with infinite solutions. So here we have two equations, but they're in standard form, okay? So we're asked to find the number of solutions to this system of equations. We have here's equation 1 and equation 2. Now before we start trying to solve it, we should just look at the equations. If I look at the coefficients, negative 6, 4, and 2, and then I look at equation 2, 3, negative 2, and negative 1, I notice that this is a half divided by 2, divided by 2, divided by 2. Or you could look at it the other way. If I look at it from equation 2 to equation 1, they're times 2, times 2, times 2. So let's get rid of that. It's easier to multiply. So let's take equation 2. We'll multiply it times 2, times 2, times 2. And if we do that, if we multiply the second equation, so take a look at what's been done here. Oh, but we need to change the signs. So we should have multiplied by negative 2, negative 2, negative 2. Well, how do you do that? How do you do that when it's really, to make sure you don't make a mistake? Okay, you put the parentheses around the left side, and you put parentheses around the right side. Use parentheses. Then you can multiply by negative 2 and make sure you distribute if necessary. So that's why it's so important. Unit 2 we learned distribution. We use these little distribution arrows, meaning negative 2 times positive 3 is negative 6x. Negative 2 times negative 2y is positive 4y. And negative 2 times negative 1 is 2. And then all of a sudden we see, okay, well, now that I multiplied times negative 2, and I look at equation 1, if I take and bring it over here, let's take a look at it. Negative 6x plus 4y equals 2. They're identical. Therefore, that's the symbol for therefore, infinite solutions. Infinite solutions. If you don't like to write the word infinite, you can use this symbol for infinity. It's a sideways 8. Okay, so that wraps up the last lesson. You will find 3 practices to do on your paper. These are also the same practices you'll find in Khan Academy. So you're going to finish these 3 problems, and then there'll be an assignment to upload your work from your paper in Google Classroom. Good luck.